Hi, welcome back, and today I'm going to be solving the USACO 2020 US Open Contest Silver. Problem 1, Social Distancing. So, Farmer John is worried for the health of his cows after an outbreak of the highly contagious bovine disease, COVID-19. And in order to limit transmission of the disease, Farmer John's and cows, up to 10 to the power 5, have decided to practice social distancing and spread themselves out across the farm. So the farm is shaped like a 1D number line with n mutually disjoint intervals up to 10 to the power 5 in which there is grass for grazing. So there's a 1D number line that's supposed to represent the farm, and there are a bunch of intervals or ranges in them. And the cows want to locate themselves at distinct integer points, each covered in grass, as to maximize the value of d, where d represents the distance between the closest pair of cows. So, in other words, the cows want to be as far apart from each other as they can, but they all want to fit in the farm, so in the number line. So, please help the cows determine the largest possible value of d. So, the first line of input contains n and m. The next n lines each describe an interval in terms of the two integers a and b, where both numbers are less than or equal to 10 to the power of 18. And here's an important part. No two intervals overlap or touch at their endpoints. So a cow standing on the endpoint of an interval still counts as standing on the grass in that interval. So please print the largest possible value of d, so the longest distance that the cows can stay apart from each other. And a solution is guaranteed to exist. So let's check this. So there are 5 cows, and there are 3 intervals, and as we can see, the intervals are listed here, 0 to 2, and these are inclusive, so 0 to 2, 4 to 7, and 9 to 9. So I'm going to be showing this first on a spreadsheet, and I've set everything up for now. So we have 5 cows, that's the value of n, and we have 3 intervals, which is the value of n. So these 3 intervals are 0 to 2, 4 to 7, and 9. So first let's try setting the value of d to 1, since it has to be greater than 0. It doesn't really make sense if the cows are 0 distance away from each other. So let's say d equals 1. Then we can have a cow here, a cow here, and so on. Oops. And basically have a cow in every single possible position where there's grass. And if d equals 2, which the problem claims is the solution, we can have, first of all, to make it efficient, let's put 1 cow here and 1 cow here. So let me zoom this in for a second. There's a cow here, cow here, cow here, and it continues. So first we put a cow here, then we go 2 units ahead and there's a cow here. And we see that this interval has ended, but if we add 2, we can still put it in another interval here where there's grass. So we can put a cow here, and a cow at index 4 and 6, and then if we add 2, we get 8, but since there's no grass there, we have to add 1, and we have to put a cow at 9. So we can get 5 total cows. How many total is this? It would be 1, 2, 3, 4, 5, 6, 7, 8. So 8 total. And if t equals 3, which is going to be the last one you check, so first we can put a cow at 0, but when we add 3, we get 3 to 0, we get 3, and we see that there's no grass there, so we have to advance forward. So we can put a cow at 4, and we can put a cow at 7, since 4 plus 3 is 7, and then 7 plus 3 is 10, but there's no grass in that range, so there can only be 3 total. We can see that the answer of the greatest value of d that supplies at least 5 cows is going to be d equals 2. So how can we implement the solution? First of all, they're going to be okay. So let's say that there are two cows, and the distance is like 10 to the power of 18. And what this basically means is that the distance, all the distances that we have to check between these two cows are from the numbers 1 to 10 to the power of 18. And obviously, that's going to take a long amount of time, and we won't be able to solve it using some kind of loop that checks each of the possible intervals. So, what else can we do? Well, what we can do is instead of checking all the intervals, we can use a binary search. And by using a binary search, what we can do is we can narrow our search each time we search for a specific distance, and then after each search, we can narrow down our choices so that we end up with one value of d. So let me show this on the spreadsheet to make it easier. So right now the maximum distance we can have between two cows is 0 and 9. So that's the maximum distance is 9, right? The minimum distance is just 1, right? Because you could have one cow here, one cow here, one cow here, and so on. And what this basically means is if we're using a binary search, then first we're going to be checking the average of these two. So that's going to be 5. Average equals 5. And what we're doing is we're seeing how many cows uh, we can space apart from each other if the distance is 5. So and then we can check how many cows we can place if the distance is the average, which is 5. And then if we can put all the cows using d5, that means that a number greater than d5 could be a possible solution. So if check works, then increase average, and if the check doesn't work, then we decrease the average, which makes sense because we have to find the greatest possible value of d that works. And if a certain value doesn't work, then we have to search lower, and if a certain value does work, then we have to search higher. Higher values, we're trying to look for the greatest distance that works. And then after this, instead of increasing the average, actually what we can do is we can change the minimum. So we can set the minimum and change the minimum to the average plus 1. And this is basically the formula of a binary search. If it doesn't work, then we can change the maximum to average minus 1. Because let's say we checked the distance of 5, and we know that we can put 1 here, we can put 1 at 5, but that's the max we can do. So we can only place 2 cows in total, right? 1 at index 0, and 1 at index 5. And since this number is going to be less than 5, we need to put 5 cows on here, but we can only put 2 if the distance is 5. So since it doesn't work, we know that all distances greater than 5 also don't work. So we can immediately rule them out and search within the range 1 through 5 for the distance. But let's say that 5 did work. Then we would know that all the numbers below 5 would provide enough cows, but it wouldn't be the answer we want since we want the largest possible value of d. So we're changing it to average plus 1, and we're continuing to check it. And we repeat this process until at one point minimum and maximum swap, which basically means that the minimum and maximum were one number apart, and the average was like the minimum. but then um, the check worked or the check didn't work, and then one number became greater or less than the other one. And then in the end, the average is the answer. So I'm going to be coding this right now, and I'm going to like create the algorithm as I go along, and I hope that can make sense to you guys, and this general idea makes sense. So first, I'm just gonna split screen for a second. First, I'm coding this in Java, so I have to import my Java classes. Oh, I forgot to put the class in first. Sorry, I thought it was already in. Public class taco social distancing server. And then I'm going to be moving the class inside to here. Yeah, there you go. And then what we need, so n is going to be up to 10 to the power 5, and m is also going to be up to 10 to the 5. We probably need a buffered reader to get in the input very fast. And we also need a string tokenizer, because there's going to be like 2 numbers per line, and we need a string tokenizer to separate those two. And we need a print writer to print our final answer of the largest possible distance that works. So we have integers n and m, and okay, so in order to store the input, we're going to have to get each of these starting and ending values, right? But the problem is, in this sample input, these values are sorted already by their starting values very conveniently, but nowhere in the problem does it state that these values are going to be sorted. So we have to make sure that we sort this value first before we look at each of the inputs, which is going to be important when we check how many cows can fit if they have to be a certain distance apart from each other. So what I'm going to do is I'm actually going to create another class called static pair, since it's going to be pair of start and ending points, and it's going to be called intervals. So let's create the class right now. Static class pair, and since we're going to be sorting it, we need to do this thing called implement comparable. So implement comparable pair. So these values can be up to 10 to the power of 8 as shown here. So A and B are up to 10 to the power of 18, so we need to use a long. So first we have 2 sets of data per each pair, and then first we initialize these. So pair long A, long B. So this class takes in 2 longs, and then it sets S as the first and the ending as the second. S represents start, E represents end. We need a class called toString, which is basically going to print out the start and end values. And what this basically does is if we use arrays dot toString intervals, then it's going to be printing S plus space plus E for each value inside. And then what we have to do is we have to do something where we add an unimplementable method called override. You guys can copy it if you don't have it right now, but it's public int compare to, and then the name of your class dot pair dot and then O. And then what we're doing here is we're going to be sorting it by the starting values. So what we have to type is if this dot O is less than O dot. this dot s is less than o dot s, then return -1 is return what. And what this basically does is if the current value of s is less than the compared value of s, then you're going to be putting the current value of s behind that value of s, so that it gets sorted in ascending order, or else you're just going to put it behind it. And this works, and you can sort an array like this using a class. I can show it when I do the initialization, but first I'll just initialize the buffer data. And then we have our buffer. New print writer, sorry. Okay, did I do something wrong? Okay. I added a few declarations, like file not found. And then first I'm going to be initializing everything. So init, I'm going to be doing that in a separate function. And I'm going to make sure that this also throws an exception, because it's going to be taking in input values, and that always needs exceptions. That's odd. Why is everything not working? Static pair. Why doesn't this work? Create class pair. I did. Oh, what is it? Init post declaration. Okay, now it works. So first we need to get n and m. So s equals new string tokenizer dot read line, which gets the first line of the input, and then n equals integer dot parse int. It converts the first string into an integer, and the string tokenizer gets the first string of the first line. And m equals this. Oops. And then we have to initialize intervals, right? So we're going to be setting intervals to new pair, and it's going to be length m, because that's the number of intervals. And then for each of these new lines, we're going to create another string tokenizer, because there's going to be two numbers per line. Intervals at index I equals new pair of, I think it's long dot parse long, because it might be a long, so we have to use long dot parse long. Long dot parse long. Leave this comma, and that works. And then at the end we have to do arrays dot sort intervals. And that's basically the initialization. We just got all the input, and now we're ready to move on to the solve portion. So in the solve portion, remember, we need to first find the minimum and maximum possible value. So I'm gonna call it low and high, because yeah, it's what we usually use when we do binary searches. And remember that we have to set them to longs, because it can be up to 10 to the power of 18. So static long, low, high, we need an average, but let's just call that middle since it's going to be the middle of the low and high. And we also need the answer, right? That we're going to be outputting. So that this distance, the greatest value of d that still can fit all the cows inside each interval. So first below equals 1 since that's the minimum possible distance, and high equals 10 to the power of 18. So instead of like actually doing it, I'm going to do 10, and then I'm just going to write out 18 zeros. Make sure you don't mess up on this because you could mess up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And one important thing is if you do it like this, you'll get an error because this is outside of the integer range. So what we have to do is we have to put a capital or lowercase l at the end, which signifies that this is a long. I prefer to use a capital L because the lowercase l looks like a 1, so it can be confusing. So it's 10 to the power of 18 as a long. Here, let me write 10 to the power of 18 so it isn't confusing. And then while low is less than or equal to high, so at one point these two are going to be one number apart and then they're going to swap. So at that point we have to stop running the while loop. So the middle equals low, the average, which is just low plus high over 2, which is the average formula. And then if check mid, and we're going to be creating another class here, another function here that counts how many cows we can put in the field if the distance is mid and they're placed optimally. Then the answer equals mid because that's a possible answer. And then we're going to be updating our search range. So low equals mid plus 1. Since we know that anything under that number will just provide more cows, but it'll be a lower value of d. But if it doesn't work, we know that any number above d is also not going to supply enough cows. So we put high equals mid minus 1. And all we have to do is system.out.println apps. So here's a somewhat tricky part. Now that we've got the idea, we need to do the check function, which basically finds the most efficient way to place all the cows given a certain d. So I'm going to write down the class first. It takes a distance as a parameter and returns a boolean, which states if it works or not. And first, we're going to need a variable that keeps track of how many cows we can put. So long cow count, let's say, equals 0. And we're going to need the current index. So let's say long current index equals, let's just put 0 for now. This isn't correct, but I'm going to be setting it here. And so what we can do is when we were checking this, what did we do? So first we had this number. We set the index as the lowest possible index, and then we kept on adding the distance, right? So if it's 0, then we add 2 to get 2, we add 2 to get 4, add 4 to get 6, 6 to get 8, but 8 doesn't exist, so we added to 9. So what we basically did is we kept on adding the distance until there weren't any pairs left, or there weren't any intervals left. So instead of this, what we can do is we can just look at each of the intervals individually, because if you look at each individual index, then that's going to take a lot of time. So what we can do is we can cycle through each of the intervals and check which cows can fit in which indexes. So for each of the intervals, Then let's the current we're going to have a current pair, so pair range equals intervals at index I. And the starting value, let's just create another variable for simplicity. Long s equals range dot s, which basically gets the start of the range, and long e equals range dot e. And what we need to do is, first of all, we need a while loop that keeps on adding the distance to the current index, and then checking if it's inside of the inside the range, basically. So while true, so the current index is going to be updated to the current index plus the distance, right? And then cal count plus plus. The problem is, where do we break out of this while loop? And we're going to be breaking out when um the current index plus the distance is greater than the end. But there is one problem with this. So first of all, there's a chance that the current index plus, so let's say that the current index was 6. We were here, we added 2, we added 2, and we're at 6 right now, okay? And then we added the distance of 2, and it's 8. And the fact remains that 8 is less than 9, so we can't possibly put a cow here because there isn't any grass. So, so what we have to do is we have to, first of all, we would break that since 6 plus 2 exceeds the end. But at this new for loop, since the current index is 6 and 6 plus 2 is 8, we have to automatically set that to 9. So what we have to do is temp index, which is a temporary index, equals math.max index plus distance and the start. So if the start is in front of that distance, then we automatically have to jump to the starting index. Um, and if this temp index is greater than e, so if it's past the end, so let's say it was at index 8, for example, and then it went 2 indexes and it's past 9, that means we can't really work on it work in that interval anymore. So we just break it. Current index would be temp index, right? And then we would add the cal count. And now there's just one last thing to consider, and that's the fact, where does the current index start? Because nowhere in the problem does it say that the first interval is going to be at 0. So what we need to do is we need to assume that the current index is going to start off at a very low number, and it's going to automatically be set to the starting index in this while loop. Because we're going to be doing math.max cur index dot dist and s, and we don't want cur index plus the distance to be greater than s. So what we can do is we can do long cur index equals long dot minimum value, and this basically ensures that it's going to be fine, and it ensures that the first cow is going to be placed at the leftmost possible value, so the lowest possible index. And at the end of this function, we just return cow count is greater than or equal to n. And it's going to be the number of cows that we need to place in the fields. So for now, I'm not going to be using these file readers. I'm going to be using the input stream reader. And I'm going to test it right now. Hopefully it works. Solution is 2. I'm gonna try submitting it in the actual USACO now. Make sure to close your input and output files because it's important to save all the changes we've made in this file. And yeah, I'll try submitting it. If it doesn't work, I'll just we need to debug it a little bit more, but yeah, it should probably work. And as you can see, the first test case is actually very fast, 165 milliseconds. But it gets slower as it goes along because these values are going to be increasing. But yeah, all the test cases passed. I hope this video helped you guys understand the problem and how to solve it. And thanks for watching.